This video is going to go over questions 1 and 2 from the Chapter 3 practice test on Schoology. So in this case we have a logarithm with sort of a unsimplified, sort of a complicated interior, and we want to talk about how we could split it up into different individual logarithms that are individually simpler inside. Remember that this x greater than 2 is just there to state the domain. You don't actually have to do anything with it. Notice that if I plugged in 2 to the denominator, 2 to the 4th is 16, and so then this thing would be undefined. And then we also know that whatever we plug in here has to be positive. Anything inside the logarithm must be positive, so that 2 takes care of that as well. Okay, so I see a couple things. Most notably, I see that I have division inside the logarithm, which means that I can split that up into two separate logarithms, one logarithm of the numerator, one of the denominator being subtracted. That's this first option. On your individual practice test, the options are probably scrambled. I don't know what I'm doing there. I'm like circling and Xing. I'm just going to say yes to that guy. But that option, hopefully we got that one. Now, the directions say select all of these that are equivalent. So we have to think about, well, could I do more with this thing? And yes, we could. There is either before I do that or after, hopefully it's obvious to us that we can actually factor these expressions, x squared minus 4 and x to the 4th minus 16. That factors as x plus 2 over, or times x minus 2 over x squared plus 4 and x squared minus 4. And so then I can take that expression and do the same thing, split up the numerator and denominator via subtraction. When I do that, the numerator will give me one of these two things, or I'm sorry, will give me this, which is the same in these two expressions. The question is, should the denominator, which I'm subtracting, have a plus or a minus in between these two terms? And if I think through it carefully, it should be the minus. And there's two ways I can recognize that. One, if I look at this as multiplication, then okay, multiplication turns into addition with my properties of logarithms, but I'm subtracting the entire denominator. So I can think about it as subtracting that addition, and then I just distribute the negative sign. So this one works. This one does not. The other way I can think about it is, well, what if we had started here? And this will help me see that distribution a little bit more easily. If I start with this top one, now I factor it here, now I can see that that negative would have to be distributed to those pieces. All right. Now we get really sneaky. Okay. If I look back at my factoring here, notice that this x squared minus 4 is actually what I started with in the numerator. So that x squared minus 4 can cancel out the entire numerator. And so I have 1 in the numerator. And there's again a couple ways I can get here, but I'm going to start with this one. I can say this is log base 6 of 1 over x squared plus 4. Now I do my subtraction property and I see that is this one. So that's nice. And then I can go even further. Log base anything of 1 is 0. That's one of our sort of properties of logarithms that we did when we first introduced logarithms, when we first talked about the graph. Every basic logarithm graph has an x-intercept of 1, 0. Also think about it as exponential, right? Log base 6 of 1, well, that equals some number. And that's saying 6 to what power equals 1? Well, 6 to the 0 power equals 1. So this logarithm, this a value equals 0. So this also works. We can also see that just by looking at the subtraction. If we look at what we are subtracting here, remember in this case I actually distributed this negative right here. I distributed this negative in, and so that's actually a negative there as well. So I'm going to kind of clean that up so we can see this more clearly here. If you just look at the subtraction and again think about, well, this is just the numerator. That is just the log base 6 of x squared minus 4. Well, hey, here's log base 6 of x squared minus 4. That's going to cancel out. So this and the whole first bit cancel out, leaving me with just that one. So there's a lot of options that work here. This middle one that we haven't really talked about yet is just does not work. It's meant to be an example of people who don't understand this exponential property, and they try to bring that 2 out front or that 4 out front. But because that's not squaring the entire expression, it's not taking the 4th power of the entire expression, you can't do that. So, no. All right, moving on. Problem number 2 is the opposite. Now we're putting these logarithms together. This one's a little more straightforward. There's not as much fun stuff I gave you to do in this case. One of the properties of logarithms that we know is that if you have, and we just talked about it briefly, if you have a power out front, you can bring that inside the logarithm and make it or if you have a coefficient out front, you bring that inside the logarithm and make that a power. And so this would be x to the 1/2, and the 1/2 power is the same as the square root. So that's definitely one thing I can do right away. Let's just say that this is log of the square root of x plus log of x minus 2. And that's this option here. So that works. Now I have addition of 2 separate logarithms with the same base, so then I can multiply what's inside. So I can take this root x and multiply it here. I would have to distribute. And if I think about it again as an x to the 1/2, not the square root of x, now I'm going to multiply that x to the 1/2 times the x minus 2. And I'll have to distribute that. And so x to the 1/2 times x would give me, well, this is x to the first, so that's now x to the 3/2, and then minus 2x to the 1/2, which is, for my question here, the first option. None of the rest of them work. If we just go through them one by one and talk about that. This is good, but this is a misapplication of the subtraction property. We said, oh, there's subtraction, I can turn that into division, but you turned it into division inside. You just said minus 2 is the same as dividing by 2, which is usually not the case. Here again, misapplication. It was plus, you turned it into multiplication, but you kept the separate logarithms, so that doesn't work. No to both of those. This is sort of doing the order of operations wrong. We took the plus and said it's multiplication, and so we distributed the x, made an x squared and a 2x, and then applied the root. But this 1/2 is not connected over here, so I can't apply that here. I have to first bring the 1/2 in, and then I can combine the 2 logs. So again, no. And then same thing here. This is really an identical statement. You've just not brought the 1/2 in. But again, you can't combine the plus part as multiplication until you've dealt with that 1/2. So, no. All right, that's numbers 1 and 2. More videos for the rest.